So there's our function. What are my possible roots? Yeah, I've got positive negative 1, positive negative 3, positive negative 9, positive negative 27. And that's from the rational root theorem. I know that going in, that's what I have to work with. So I want to start trying those numbers out. There's one other possible pitfall here I want to be careful about. This one has 4 terms, but what degree is it? Fourth degree, and we call that quartic. Quartic because it's 4th degree. Quarters are a fourth of a dollar. 4 quarts to a gallon. So quartic goes with 4th degree. So when I go to do my tests, you want to be aware of that. So when you start to run your numbers through, remember to include a 0x. And that's going to make a difference with these. Right. Exactly. So now anyone want to take a guess what we should start with? We don't have 2 to work with. I guess we could start with 1. Start with negative 3? What the heck? And really, you just got to try something. So let's start with a negative 3. So 1, 8, 18, 0, and negative 27. We're going to cross our fingers and negative 3 will work. So 1 times negative 3 is negative 3. 8 plus negative 3 is 5. Takes me up to negative 15. 3, negative 9, negative 9, positive 27, 0. We've got a hit. I've got one of my roots. I have 3 to go. So the idea here is rather than rewriting this up here, I'll rewrite the exact same expression, but I'm going to write it in a factored form. So I'll write x plus 3 because I know negative 3 is a root. And then I'll write my quotient that I got from doing the division. So since I know this worked out, I can write x to the third plus 5x plus 3 minus 9. And the other advantage, I don't need to worry about testing 27 now.
Where's the x root?
Oh, good call. They're there. So now the question is, can I factor the new cubic expression? Same procedure. I'm looking for possible factors, which at least now the list is a little smaller. Positive negative 1, positive negative 3, positive negative 9. I would try to factor by grouping, but it's not pretty enough. So I'm going to have to fall back on these other guys. I don't know. Anyone want to take a guess what we should try? Try what? Yeah, but which factor are we going to try it with off our list? 3 again? Try positive 3? Okay. Try positive 3. If that doesn't work, we'll try a negative 3. Then we'll try the 1s. I'm not liking 3 for this, but we'll see what happens. I'm not liking 3 because I'm looking at those numbers. They all seem kind of close. I don't know what 3 is going to do to them. So 1 comes down, 3 goes up. 8 times 3 takes me up to 24. Yeah. 71. Yeah. Well, no. Let's be good. Let's do it right. 81, and that puts me at 72. Positive 1's good. All right. Yeah, that definitely does not work because I have a remainder is not 0. So that tells me conclusively I'm not looking at a factor. So I can just pull that right. No, I don't. Wow. I don't have a factor. Quite the opposite. It's not a factor. Jeez. 1 will work? Yeah. Let's try that. Put that over there. All right, let's try that 1. So let's see. We put in the 1. So 1, 5, 3, negative 9. 1 comes down as 1, 1, 1, 1, 6, 6, 9, 9, 0. Cool. And what that tells me in my work is I can go from here to here. Now I'll go a step further. I've got x plus 3, x minus 1, and now I've got x squared plus 6x plus 9. Remember, you change the sign when you write it as a factor. That's right here. I did. It's negative 3 in the box, so it's positive 3 here when I write my factors out. And now I've got a quadratic. We go find our friend who's taking algebra 1. We say, hey, you know how to do these. You practice them. Here, more practice for you. You're welcome. Exactly, because who doesn't want more practice? I don't know. Right about now, I think the Red Wings would be happy for some practice. Just saying. Just saying. Yeah, well, not all. Hey, our curling team is... Never mind. Exactly. Now, I take this last guy and factor him. And that's not so bad because it's going to be x plus 3, isn't it? Yeah. So x minus 1. And then this factors is x plus 3, x plus 3. So if I write all of my factors out short form, I have x minus 1 as a factor, x plus 3 to the third. So my roots, or my zeros, are going to be 1 and negative 3 with multiplicity 3. I'll take it. Why do you have to state that? Because that actually answers the question. The question is, what are the roots? So my roots are 1 and negative 3, but 3 has multiplicity 3. And we emphasize the multiplicity because if I were to go up to another mathematician, we're working on some physics project. We're trying to get some equations to work to predict a satellite. And he gives me this function to solve. And I know it's a quartic function. Or he knows it's a quartic function. So we know what it is going in. If I give him just 2 answers, he's going to say, dude, where's the other half? I asked you to solve a quartic, you gave me 2 solutions. So I include, is it what? Right, because we're going to change the sign. I say 1 and negative 3, and that multiplicity 3 says if that counts 3 times, I have all 4 of your answers for you. If I get audited on my mathematics, that's what we would look at then.